Hello guys, welcome to another edition of our studies on functions. Today we are going to talk about surjective and injective function, which we will get to the understanding mappings and their uniqueness. Okay guys, let's move to definition of surjective function, which is also known as onto function. A function f is said that A mapped to B is surjective if every element in the codomain B has at least one pre-image in the domain A. What it means is that the codomain is a set that contains the possible images, and the range is a set that contains all the images. So if it happens that the range of function f become the same as codomain of function f, then what it means is that every y in B has an x in A such that f of x equal to y. So anytime this scenario or this situation happen, then it means that the function is onto. So what you can put in your mind is very simple. A function is said to be surjective or onto if the range of that particular function become the same as the codomain of that same function. Definition of injective function. An injective function is the one that we called one-to-one function. So a function f of f is said that A mapped to B is injective if different elements in A map to different elements in B. So this is very simple. A function is said to be one-to-one function if different elements in A map to different elements in B, which means that mathematically, if f of a1 become the same as f of a2, so if the function is one-to-one and f of a1 is the same as f of a2, then a1 is equal to a2. So no two elements in A are mapped to the same element in B. We have to put that one in mind. That is the reason why it is even known as one-to-one function. One to one. And one-to-one is known as an injective function. So let's move to the next one. And we have something we call horizontal line test. A function is injective if no horizontal line intersects the graph of the function more than once. So if you see a function and the function is one-to-one, then the function have to pass this particular test, and the test is horizontal line test. So the horizontal line is the line that we drawn, which is parallel to the x-axis. So look at this particular graph. It is injective function, and this particular function here, which is f of x equal to x power 3. So that is x power 3. So the blue line here is the graph of x power 3. That is its movement on the plane. So when you draw the horizontal line, this is the horizontal line, it intersects this particular graph at just one particular point. So this means that this particular graph passes the test, and it is an injective function. In other words, it is one-to-one function. Let's move to the next graph here at this side. The text is used, we have this graph of f of x equal to x squared, and it is a U-shaped parabolic curve. So when you look at this particular function or this curve, and you draw the horizontal line, we are expecting the horizontal line to intersect this particular curve at one point. But what do you see here? We are having 2 points of intersection. So which means that this particular function fills the horizontal line text. As such, it is not an injective function, meaning this particular function fails to be a one-to-one function. Let's also talk about a function that is strictly increasing or decreasing. A function is strictly increasing if f of x1 becomes greater than f of x2. So if f of x1 is greater than f of x2, then the function is increasing automatically based on the fact that x1 is greater than x2. Then strictly decreasing, it means that f of x1 will be less than f of x2 when x1 is greater than x2. So here the x1 is greater than x2, but when you substitute such input into the function, we are going to realize that their respective images will be in this kind of range or relation where the image for s1 will be less than the image for s2. Anytime you see a situation like that, it means that the function is strictly decreasing. So here the x1, which is greater than the s2, produces image which is less than the image produced by the s2. Good. So strictly increasing or decreasing function are always injective. So we should put that one in mind. So injective functions can also be in the form of a function that is strictly increasing or decreasing in its movement. Okay, so let's move to the next one. Let's see an example here. We have example 1. F of x equal to 3x plus 7. We should show that f of x, this particular function is injective or one-to-one function. So if it is one-to-one function mathematically, then f of x is equal to f of y. So let's see if it will pass the test per our calculation here. So f of x is 3x plus 7 and f of y is also 3y plus 7. So at this point, the input becomes y. So where I see x, I'll put the y there. So if it is one-to-one or injective function, then at the end of our simplification for this particular relation here, we should end up seeing that x is the same as y. So here, 3x plus 7 equal to 3y plus 7. The plus 7 here will cancel the plus 7 here. Then we end up with 3x equal to 3y. So when you divide both sides by 3, the final result will be x equal to y, which means that if f of x equal to f of y, then simply means our x equal to y. Hence, this particular function qualifies to be a one-to-one function. So you can say that hence the function is one-to-one. Let's move to another example, which is in the form of a rational function. So we have f of x being equal to f of y. That is the relation for one-to-one. If this function is one-to-one, then this relation have to be simplified to get to the point where x will be equal to y. So per our calculation, that is where we are going to substitute the y here, x is also here, and we expand algebraically. So this one is the same as 5x on 4, then plus 7 over 4. Here too will be 5y on 4, then plus 7 over 4. So when 7 over 4 will cancel 7 over 4, then we are going to left with 5 over 4x here, 5 over 4y here. When you divide both sides by 5 over 4, we are going to realize that x is equal to y. Hence, this one passed the test and it qualifies to be a one-to-one function. So more examples of one-to-one functions or injective functions are here. So we can see this one here is one-to-one. We can also see this one here. It is also one-to-one based on the condition given. So we have f of x equal to x squared. So when you substitute, you are going to end up with x squared equal to y squared, which means that x is equal to plus y or x is equal to minus y. But since we are having a condition that x is greater than or equal to 0, it means that it can be negative. So automatically S is equal to Y. So this qualifies to be one-to-one function in this bounded range. Good. So within this bounded range, it is one-to-one. So let's move to the next one. For this case, we are having X equal to plus or minus Y. There is no condition here as like the example number 4. So here it means that we are having two answers corresponding to X, which means that X is plus Y at the same time X is minus Y. And it means that this particular function fails to qualify to be one-to-one function or injective function. And we can also look at this particular example, log 10 of 3x minus 1. Log function is strictly increasing for s greater than 1 over 3, which implies this particular function is also qualifies to be one-to-one function. Good. So real life application of injective and surjective function. So let's see this example here. So if I want to know real life application, that is real application of one-to-one function, look at these examples, and it is very, very interesting. Each student ID assign each student assignment, rather, each student ID assignment. Each student receive a unique ID. So when they go to school, as we are students in our senior high school, we have unique ID numbers, and our ID numbers are only corresponding to ourselves. That is one student to one ID number. So username or email system. So your email address too is one-to-one. It corresponds to only your account, and each user account has a distinct identifier. Barcode system. Each product has a unique barcode to prevent duplication. So when you buy a product, you can see some barcode on the side or on the top of the product. This barcode is very unique. It's unique to this particular product, and it is there to prevent duplication. And we can also talk about subjective, that is onto application. So we can scheduling system. Every available time slot is filled by at least one task. Yes. So job assignment, ensuring every position is filled by someone. So when you go to institutions, the job assignment is can also be termed as an onto function because every position is filled by someone to work on. And we also have distributing resources to that every receiver, that is us, will get at least one supplier. Yes. Then we can also talk about bijective applications where it is both onto and subjective. So let's see. Uh, Exams sitting plan. Every student gets one unique seat, and every student is used and every seat is used. So here, when you see is the student is assigned to one seat, and every seat in the examination room is used. So when it happens like that, then it means that the situation or the relation between student and the seat is both one-to-one and onto relation. So we have matching staffs to tasks. Each task is assigned to one staff member and all tasks are covered. Yes, so this one is also a practical application of injective and surjective function. So the combination of both injective and surjective functions are what we call bijective functions. Good. Thank you very much.